Here we will examine the three types of dense fibrous connective tissues. So remember that these are dense fibrous because their fibers are packed closely together. So we'll start with dense regular connective tissue. Now, dense regular connective tissue is generally found in both tendons and ligaments. So the primary attributes of this tissue are that the fibers of dense regular connective tissue are mostly made out of collagen, and these collagen fibers are arranged parallel with one another, which is why this tissue is called regular, since the fibers have a parallel or regular arrangement. The purpose of this arrangement gives the function of this arrangement gives the dense regular connective tissue great tensile strength. Now, this word tensile means that this tissue is really strong under tension or pulling forces. And because the collagen fibers are arranged in parallel with one another, this tissue has a great tensile strength from forces being applied in one direction. So it's essentially behaving as a piece of biological rope or even steel cable, since collagen fibers actually have a greater tensile strength than steel fibers of the same size. So collagen is a really strong fibrous material in the body. So for the reason, or I should say, the dense regular connective tissue is able to resist tension in a single direction because of the regular arrangement of its collagen fibers. The functions of dense regular connective tissue in ligaments is to bind bone to other pieces of bone, because ligaments are structures that bind bone to bone. And tendons help to transmit muscle forces to bone. So tendons bind skeletal muscles to bones, but tendons do not stretch out when muscles apply forces to them. So what that means is that the pulling force that the skeletal muscle is applying to the bone is not lost in stretching the dense regular connective tissue tendon out. So dense regular connective tissue tendons help to more effectively transmit the pulling forces that the muscles are exerting to the bones themselves. Okay, so that is dense regular connective tissue. Let's turn our attention briefly to dense elastic connective tissue. The primary locations of dense elastic connective tissue are large arteries called the elastic arteries. The elastic arteries are the arteries that are in closest proximity to the heart, and these are the arteries that are receiving blood after the blood is pumped out of the ventricles of the heart. And so immediately after blood leaves the heart, it enters the large elastic arteries, and then proceeds to the rest of the body. One example of these elastic arteries is the aorta, which is the large artery. It's actually the largest of the, in terms of diameter of the arteries in the body, and it receives blood from the left atrium of the heart. So the elastic arteries are made of this dense elastic connective tissue. As the name dense elastic implies, the primary fiber type that we see in dense elastic connective tissue are elastic fibers. And elastic fibers are really known for being able to stretch under pressure. So that is, they can stretch when a force is applied, and they can recoil after that stretching force is removed. And so this is really what makes elastic connective tissue different than collagen-based connective tissue, because collagen-based connective tissue doesn't really stretch in the same way that elastic connective tissue can. Now we also see that we see that dense elastic connective tissue is made out of elastic fibers, but we see that they have the same arrangement as in dense regular connective tissue. That is, these elastic fibers are parallel to one another, and so much like the dense regular connective tissue, we see a parallel arrangement in the elastic fibers that are present in this particular tissue here. So because dense elastic tissue has the ability to stretch and recoil, dense elastic tissue essentially behaves as a biological rubber band. So we can apply a force to it, it will stretch out, and then after that force is removed, it will return back to its original length and shape. And so this is really of great benefit to the elastic arteries, where the elastic arteries stretch when the heart pumps, and their stretched out walls continue to keep that blood under pressure even when the heart relaxes. So even between heartbeats when the heart is relaxing, this helps to keep a high pressure on the blood so that it can continue moving away from the heart and going to the rest of the body with really very little trouble. And so it's important, this dense elastic connective tissue helps keep blood under pressure between heartbeats, even after it's left the heart as well. So we've seen dense regular and dense elastic connective tissue so far. The last of our dense fibrous connective tissues is dense irregular connective tissue. We have a variety of locations for this connective tissue. Primarily it's found in the dermis of the skin, so the majority of the deep layer of our skin called the dermis is made out of dense irregular connective tissue. We also see this tissue surrounding the or making up the capsules that surround the joints of our skeleton. And so at these joints that are called synovial joints, we see that a majority or a lot of the tissue that the joint capsule is made out of is dense irregular connective tissue. And we also see that dense irregular connective tissue makes a strong fibrous covering around things like the kidneys, the bones, cartilages, muscles, and nerves. And so we see this as a thin but strong wrapping around these structures here. So for example, in the bones, we see dense irregular connective tissue wrapped around as a very thin layer wrapped around the superficial surface of our bones. We'll later learn that this covering is called the periosteum. But basically what it does is it helps provide some structural support to the bones themselves, but then it also provides a tough anchoring surface to allow blood vessels and nerves to attach to the superficial surface of the bones. The periosteum also helps to as a muscle attachment point so that muscles can attach to bones, and when those muscles pull on the bones, this dense irregular connective tissue will help effectively transmit, but then also resist those pulling forces so that the bones when the bones have a force applied to them in a single direction, they'll move without too much hindrance there. And so the dense irregular connective tissue helps make sure that when the muscles pull on bones, that pulling force is transmitted effectively so that the bone will move as it should. We also see a large layer of it. This is just a photomicrograph through the skin. We see this layer here, that's the epidermis here. So, and then the deeper layer of our skin here is called the dermis, and most of that dermis is made up of dense irregular connective tissue here. Now, the main attributes of dense irregular connective tissue are that the primary fiber type of dense irregular connective tissue is collagen, so just like we saw it in dense regular connective tissue. But these collagen fibers have a more random arrangement, which is why we give the name irregular to this tissue, because these collagen fibers are arranged more randomly. Now, the benefit of this random arrangement is that the tissue resists tension or pulling forces from many different directions because of the way that the fibers are arranged. And so because dense irregular connective tissue has that random arrangement of fibers, it's a good connective tissue to help resist any kind of stress or pulling forces that can come from really many different directions, not just one direction. And this is also a great connective tissue that helps provide external structural strength and support because it's generally found wrapping a lot of soft organs. And so for those soft organs, it helps provide an outer casing that has great structural strength and support.